Hello everyone, welcome to Yourpedia Education. So today I am here to discuss one more subject that is related to signal and system. I am going to discuss some basic properties of signal and system, right? That is related to BEL. If you want to give your BEL exam, this is most important subject for you, right? That is what? That is signal and system, right? If you are going for BEL exam. See, last time what we observed that most of the questions are theoretical, even from the network or signal system and communication, every subject there is no solving question, all the theoretical questions. So today I am here with you the basics of signals and systems, how we deal them, what are the properties there, and I am discussing all aspects about that. So if you are not start your preparation for BEL exam, you should start preparing for that exam. Why? The form filling is already started, and I think last date is nearby. I think it is 11th, right? I don't know the exact date. Sir already uploaded one video on that one, so you can go through that one. One thing, the after the releasing of after the, you can say, the completion of form filling, you will have only 2 months, 2 max 3, right? We are observing that only 2 months we will have, and you have to cover all the subjects. So for that one you have to start preparing right now. And one more thing, it is not a difficult exam. As you see, the gate exam is difficult. Some of the students think that that exam I can't crack, but this exam is not like that, that you can't crack it. It's a easy exam, its pattern is easy, it's covered lots of things, but the easier, you can say, the questions are easy as compared to the other exams, right? So we are going to discuss today signal system, right? Let's start with signal and system. Right, this is fundamental concept and signal properties, introduction to signal and system. See, what is signal and what is system? The first thing, signal is what? Signal is anything which carry the information inside that one. Like voice is also a signal, music is also a signal, video is also a signal. So all the signal, all the quantity, or you can say all the entity which are carrying the information inside that one, that is called as signal. Understood? And system is what? System is a physical combination of the objects which will take a input and produce a desired output. That will be your system, right? Okay. Next is type of signals. Basically, when we studied that signal is nothing but that convey the information inside that one, that is a signal. One more thing you have to remember, that signal is not only the function of time, because in signal and system we generally study the signal which are function of time, but it is not necessary that every signal is a function of time. They may be space coordinate, right? The signal can be function of time, space coordinate, and any other quantity. Let's take, you are having a video signal. Video signal is a function of time as well as the space coordinate, because if you are displaying a picture on the screen, that every pixel has its location, and you have to send a signal which is a function of space coordinate as well as time, that at this particular time you have to show that much brightness. After this time, after let's take 0.1 microsecond, you have to display this brightness, like that, right? So basically, when you are seeing a picture or a movie, right, you are seeing a video signal, that video signal will have function of time as well as the space coordinate. And in photos we are having only the space coordinate functions, right? And generally time domain signal is scientist time domain signal, which is a function of time. So what we can say, the signal are the quantity which may be a function of time as well as the space coordinate, right? We are here in the signal system discussing only one thing, that is a function of time. We are not dealing with the signals which are the function of space coordinate here, right? We are discussing the space coordinate functions are in image processing. That is not the part of this one, right? Okay. The first thing is type of signal is continuous time signal. Continuous time signal is what? Whenever you are having a signal, let us take, we are taking an example, that is xt is equals to sine of 2 pi ft. This is a continuous time signal. Why it is a continuous time signal? See, let us take, you are defining a signal which is from T1 to T2. This is called its domain. In its domain, it is taking value at every instant of time. You can see at every instant of time it will take the values, like at t1, after t1 if you are moving 0.01 distance towards the right, then it will take the value. So what we are observing here, that a continuous time signal will take value in its domain at every instant of time. That is called as continuous time signal. Like sine of 2 pi ft, it is a graph of sine of 2 pi fct, like this, right? It is 0, this is here 1, not 2 pi, 1. So this is the graph of xt is equals to sine of 2 pi fct. So this is also a continuous time signal. So how we can define a continuous time signal? A continuous time signal is defined for every value of time, right, in its domain. The example is xt is equals to sine pi t. Okay, yeah, this is the graph of this one. Next thing is discrete time signal. Discrete time signal means what? Let us take you are having a continuous time signal xt, right, and I give this signal in the input of a switch. This is a switch which will close at a particular instant of time. Let us take t is equals to nt, right? This switch is open rest of the time and it will close only for the integer values of this n, means n equals to 0 it will close, then n equals to 1 means at t time it will be again closed. So what it will do, it will pass, let's take you are having a sinusoidal signal like this, it will pass the first value at t equals to 0, then n equals to 0, then n equals to 1, then it will be passed the value at t, 2t, 3t, only the discrete interval of time it will pass the values. So what we are observing here, this is a continuous time signal. Now we are having a discrete time signal, right? Discrete time, because it will take the values at a discrete interval of time. So whenever you are defining a discrete time signal, then this, in place of small t, what we have to do, we have to replace nt. So it is become x of nt. Generally, to define this signal, t is generally considered as a 1, and that x of n is represented the discrete time signal. So whenever we are going for the discrete time signal, to convert a continuous time signal into discrete time signal, we are having a process that is called sampling. So sampling is a process which convert a continuous time signal into discrete time signal, right? So in discrete time signal, what is the difference between these two? The continuous time signal, in its domain it will take the value at every instant of time, but discrete time signal will take the value at a specific instant of time, like 0, 1, 2, 3, like that, right? So what we can say, the discrete time signal is discretized at the time, right? Yeah. Okay, what are the example of these signal? That is digital audio samples. So basically whenever you are store a things inside a computer or anything, so because the computer will also only know the zeros and one, it is not knowing the continuous waveform, so that means we have to convert that into discrete time signals. So where the image, video and everything will be stored in the discrete time signals form. So digital audio samples, digital image, sensor reading at a discrete interval of time are the discrete time signal. So these are the properties of discrete time signal. Domain, continuous time, and discrete time means discrete in n. Representation, analog waveform and sequence of samples. Processing, analog system, and this is digital signal processing. So to study the analog waveform, we generally do the analog system processing, analog signal processing. Analog signal processing nowadays is not a we are not using that analog signal processing, because we are totally moved from analog to this digital form. So digital signal processing is the most important thing nowadays, right? So digital signal processing is the processing of digital signals, discrete time signals, right? Okay. Now one more thing you have to understood here. There is a two more things are here. That is analog signal. Analog signal. When we talk about the analog signal, right, This is the fourth type of signal. Because we are discussing continuous time, discrete time, now we are going towards the analog signal. Analog means which is continuous in amplitude this time, not in time. We are not talking about the time. This time we are talking about the amplitude. Let's take, it is defined from A1 to A2. So in this amplitude range from A1 to A2, it will take every value, right? It is not taking the specific value. Let's take, it will take A1, then A1 plus 1, A1 plus 2, A1 plus 3. No, it will take the values at every, you can say it will take the values which is lying between A1 to A2. It will take any values, not the specific value. That's why it is called as analog signal, right? And another one is digital signal. Digital signal means what? Which will take the value at a specific amplitude. Means it will take, let's say here it will take 2 value, then 4, then 6. It will not taking the values between 2 and 4, not taking the value between 4 and 6. It means this signal is digital signal. So there are the combination of these four. First one is what? Analog, continuous time, analog signal. That example of that signal is this, where we see that in time domain, in time axis it is continuous, in at amplitude axis it is also continuous. That signal is called as continuous time analog signal. The another signal is what? Discrete time analog signal. Discrete time analog signal. What is the difference between discrete time and continuous time? So this time is discrete time analog signal. So discrete time analog signal is what? At time axis it is discretized, means it will take the value at n equals to 1, 2, 3. But amplitude can take any values between, let's take A1 to A2. So at n1 it will take the value 1.1 something like that. Then at n equals to 2 it will take the value 1.252 something like that. So it will taking any values, not a discrete values at the amplitude axis, right? At amplitude axis it will take any value. So what we can say, this is discrete time analog signal. Next is continuous time. Let's take the fourth one is continuous time digital signal. Digital signal this time. Digital means the amplitude is discretized. So continuous time digital signal is what? This example is there. Because in time it is continuous, it will take at value at every instant of time, but at the amplitude it discretized. It will take at 2, 4 and 6. So these are the values. So what we can say, this is continuous time digital signal. Next one is discrete time digital signal. Discrete in time and discrete in amplitude, digital signals, right? So what will be the example of that one? It is taking, let's say amplitude here 1, then after amplitude 1 it will take the next amplitude as 2, next amplitude as 3. So it is taking the discrete amplitude as well, right? Time is discretized and amplitude is also discretized. That is called as discrete time digital signals, right? Next, so these are the types of signal. Next is energy and power signal. So energy and power signal are the fundamental quantities. With the help of these quantities we can measure the strength of any signal, right? How much strength that signal will have. Energy of a signal is defined by this formula, that is integration minus infinite to infinite mod of xt square dt. If this energy is less than infinity, what we can say, this is a energy signal, right? Next is like pure pulse signal, decaying exponential signal are the energy signal. These are the example. Another thing is power signal. Generally the power signal are those signal which have infinite energies. First we go for the energy. If energy infinite, then we will go for the power. So power of any signal is defined as by this formula. If power is finite, then only we can say this is a power signal, right? This is called average power. And always remember, the power of a energy signal is 0, and if you are calculating the energy of a power signal, that will be infinite. right? These are the example that all the periodic signal generally are power signal, right? That's the property. Property is energy. Energy of a energy signal is finite, but power is infinite. Power of a energy signal is 0, but power of a power signal is finite. Yeah. Examples are pulse and sine waves, non-periodic and periodics. Okay, periodic and aperiodic. Generally, when we are talking about periodic signals are those signals which will repeat itself after a certain interval of time. That interval of time is called as period. So, if we define a periodic signal that xt is equals to x of t plus capital T. If any signal satisfying this property, that is a periodic signal. In discrete domain, if any signal is you can say satisfying this property, xn is equals to x of n plus 1, that is also a periodic signal in discrete domain. So these are the example of periodic signal, and this waveform. This is a waveform, periodic waveform, because it will repeat itself after a certain interval of time, but this will not repeating itself. That's why it is a aperiodic signal. Yeah. Even and odd. Even signal are those signal which are symmetrical about y-axis. Symmetrical about y-axis. If you make a graph of even signal, that will be always symmetrical. Always symmetrical about y-axis. This is the example of a even signal. And if you go for mathematical expression, then xt is equals to x of minus t. If any signal is satisfying this condition, that will be even signal. These are the example of even signal, that cos t, t square e raised to the power mod t, right? These are the example of even signal. Odd signal, whenever your signal is symmetrical in opposite quadrant, either in first or third or second and fourth quadrant, then that will be a odd signal. And if the signal satisfying this property, x of t is equals to minus x of minus t, then that will be a odd signal, right? These are the example of odd signal. You can see that is the example of odd signal. Decomposition of even part and odd part. See, if any signal is neither even nor odd, then generally we decompose that one into two parts, that one even component of that signal and odd component of that signal. The even part of that signal given by this formula, that is x of t plus x of minus t divided by 2, and the odd part is given by x of t minus x of minus t divided by 2. And then if you know the even part of any signal and the odd part of any signal, you can reconstruct back that signal from that one by using this formula, x of t is equals to x even t plus x odd t, right? So these are the basic properties of signals which you should know, right, before going to the next things. Next, signal classification based on signal property, right? Next is causal signal. Causal means the signal, yeah, this is talking about system, right? System classification based their system properties, right? See, signals are also causals, right? Causal signals are those signals which are 0 for t less than 0. When we talk about the system has three types of input: present input, past input and future input. Present input of the signal is xt, past input of signal is xt minus t naught, and future input of that signal is x of t plus t naught. These are the three inputs here: present, past and future input. So whenever you see xt is present input, x of t minus t naught is past input, and x of t plus t naught is future input. So whenever we are talking about the causal signal system, causal system are those systems whose output will also will only depend on the present as well as the past input. That are the causal signals systems, right? Non-causal, in the system, if the output depend on the future value as well as the past or present values, that are the causal, right? And if you are talking about the signal, the causal signal are those signal whose value, if x of t is 0 for t less than 0, and yeah, only this thing. If any signal satisfying this property, x of t is equals to 0 for t less than 0, that will be a causal signal. System, if we are talking about the system is causal system is that system where the output depends on present as well as the past input to that system. Next is linearity. Linearity, if a system is linear, that should be satisfying these two property, additivity and homogeneity. superposition or homogeneity. Additivity means if you are giving x1t input, y1t as output, x2t input, y2t is output, then if you combine them together, the output should also be added together. If homogeneity means if you multiply the input with any quantity, then your output should be multiplied with that same quantity. Example, this is a linear system, this is a non-linear system. Time invariant and time variant. Time variant invariant means a system whenever you give the input, you delay the input, the same amount of delay will be going out to be in the output. If any system satisfy that one, that is time invariant, otherwise time variant, right? Example is time invariant system, this one is time invariant, this is time variant. Stability. Stability, when we are talking about the signals, signal and system stability, that generally considered as BIBO stability, bounded input, bounded output. You are having a system, you give an input, a bounded input, the system output should be bounded. If the system will produce unbounded output for a bounded input, that will be unstable system for us, right? So let's take this example. This is 2xt, this is a stable system. If you give the bounded input here, if you give the xt value bounded, which is less than infinity, then yt is always less than infinity. But here this is unstable. Why? If you replace the t value is infinity here, the xt is finite for t infinity, but e raised to the infinity is going to be infinity, which make this output will be unbounded. So what we can say, this system is unstable, right? Invertible system are those system if a distinct, see this is the definition for that one, how you can check that the system is invertible or not. But invertible system means what? You are having a system as if the xt is the input and it is producing the output yt, and this yt is given to another system si, which is producing the same input which is given to the first system. Then only we can say if there is physically exists a system si which produce the same output which is given in the input of the first system, right? That second system is called as inverse of first system, and first system is called as invertible system. So if there exists a SI system, a system such that it will produce the same output which is given in the input of the first system, then only we can say the system S is invertible system, right? So yeah, what are the condition? The condition is that non-zero input should not produce the zero response, and distinct input produce the distinct response to that system. Then only we can say that that system is invertible, right? This system is invertible, this is not invertible, because if you are having x square, it will produce the same output if you give 2 and minus 2. So two distinct input gives the same output. That's why it is non-invertible system. Signal operation means time shifting. This is called delay, right? And this is called advance. Delay means if you are having xt plus 2, this is xt signal, xt plus 2. So this signal, this complete signal will be shifted towards the left by the 2 value. And next is time scaling. Time scaling means, yeah, this is t plus 2. Similarly, you can go for t minus 2. If I am drawing the graph of t minus 2, that will be shifted towards the right by these 2 values. So 2 to 4, like that. Next is what? Time scaling. Time scaling means if you are having a xt signal, right, like that, there are two things, the compression and the expansion. If this a value is greater than 1, that is compression, a lying between 0 to 1, that is stretch or expansion of that signal, right? So if you are having a xt signal like that, if I am doing the scaling x of 2t, it means all the time values will be divided by 2, all the time values, right? So that's why it is become from 0 to 1. Amplitude scaling. Amplitude means when you are multiplying the value, only the amplitude value will be multiplying that one. Time reversal, you have just make the mirror image about the y-axis. If you have signal like this, you have to make a mirror image about that one. That is time reversal. So these are the some frequency domain property. We will discuss that when we completed the Fourier transform. So these are the some questions which are related to this one. You can check that and solve these questions, and you can check your answers from this PDF, right? So this is the PDF from related to this lecture, and these are the some questions which you can tackle. These are the some questions which are relevant for BEL. You can check them. Okay, hopefully this information will help you. One more thing, if you want to prepare, Yourpedia is already start their module for that BL preparation, right? You can join that one, and live classes are going on. You can watch that, and already YouTube we are uploaded several live classes. You can watch them what we are what we are teaching there, right? Hopefully this information will help you. Thank you.